In this video, I'll be demonstrating a work-in-progress version of an Enigma Cipher machine emulator, a project I've been working on the last month and a half or so. For those of you who don't know, Enigma machine was a electromechanical cipher machine used by, among others, the German armed forces during the Second World War, and it's probably the most notorious cipher machine in history, because while the Nazis thought the Enigma cipher was unbreakable, in fact, the Allies were able to decrypt many messages through the cryptological efforts of the Poles first, and then the British, and to an extent the US. There's a fair amount of detail here on the Enigma on Wikipedia, including the main article and some sub-articles. Before I say anything else, it's important to note that this project of mine is in no way groundbreaking or original. There are many Enigma emulators out there. In fact, I used, this is another great site too, by the way, on Crypto Museum. I used this Enigma emulator online and this one here to validate the output of my machine to make sure that it's actually producing correct results. Okay, let's launch the app. As I've noted in some of my previous videos, this is the Qt Creator IDE. Launch the app from here. Here we are. So the application allows you to choose from among 3 of the Enigma versions that were used by the German armed forces during the Second World War. So you've got the Enigma M1, which was used, the Enigma 1, which was used by the Wehrmacht and the Luftwaffe. Then you have the M3, which was used by the Kriegsmarine, and the M4, which is also used by the Kriegsmarine. The Enigma 1 and the M3 both have 3 rotors. The M4 added a 4th rotor. You notice that there's no accept or OK box yet. That's only enabled when the machine has been validly configured. So let's start by, why don't we go with the 4-rotor Kriegsmarine version M4. So in addition to the selection of the basic Enigma model, the configuration aspects are as follows. You've got the 4 rotors. There's discrete types of rotors depending on the model of the Enigma machine and the branch of service. So the Enigma 1 has 3 rotors. There's 5 rotors to choose from and 3 rotor positions in the machine. The Enigma, the M3 version also has the first 5 rotors that are available for the Enigma 1, but the Kriegsmarine added 3 additional rotor types, 6 through 8, and the M4 also has the 8 rotors, but the 4th rotor position only accepts 2 of these special rotors, the beta and gamma versions. And each rotor type had a unique internal wiring that effectuates a substitution cipher. So, for example, a type 1 rotor, an A would be encoded as an E, a B would be encoded as a K, a C would be encoded as an M, and so on. So in addition to selecting the rotors, you're basically selecting the positions in which the rotors are installed. So each Enigma machine would come with a collection of, let's say if it's an M4, it would come with the 8 basic rotors and also the 2, the beta and the gamma rotors for the 4th position. So you would choose, let's just say we go with a number 5 rotor in this position, a number 3 rotor here, and a number 7 rotor here, and then the 4th position, let's go with the gamma. So that's you're choosing the types of the rotors and the order in which they're installed in the machine. In addition to those aspects, there's the so-called ring setting. Without going into detail, the ring setting is, it's kind of like a rotor within a rotor. It allows you to effectuate a Caesar cipher on top of the rotor's own substitution cipher. I'm not going to try and explain it. You can find much more detail than I could possibly give on the Wikipedia page or on the Crypto Museum description. But we can set the ring positions here. Let's set the first rotor to W, the second rotor to D. We'll leave the third rotor in the A position. And this is not actually a ring setting, but because this ring doesn't rotate like the other ones do. But let's just set that to T. Then another aspect of the machine to be configured is the so-called reflector Umkehrwalz. And the M4 version came with these special thin versions of the B and C reflectors. Let's just go with B. And then the final one, the final aspect is the plug board. You notice now, because plug board settings are optional, but we've selected the model, we've selected the rotors, and we've selected the reflector, so now the OK button is enabled. The plug board, it basically allows you to transpose pairs of keys so that, for example, an A typed by the operator might be converted to an L before being routed through the machine circuit path, and the L would be converted to an A. So it's kind of like reciprocal swapping. So we can do that here. This is basically the A position. The way you connect plug board positions is just by clicking. So these both are red, so they're connected. We can connect 5 and 21. 8 and 18, and if you want to unplug something, you just click on an existing connection and the color is removed. Let's just do these, doesn't really matter. For what it's worth, the machines, this probably doesn't make a tremendous amount of sense, all of these settings. The machine settings would be specified by a code book issued to the various command echelons. This is an example of one. I think it's a real one. It's been declassified at some point. This is a code book settings for a 3-rotor model. You can see it has a separate setting. Each row is for a separate day of the month. So the settings change daily. So you can see the Walzenlage. This is the rotor selections and the order in which they're put into the machine. So in this case, on the 31st day of whatever month this was, you would have a type 1 rotor, type 2 rotor, and a type 5. I think these go from right to left. Ringstellung, that's the ring setting. So this is how you would set the ring settings, which are these values here. These values. The Steckerverbindungen, those are the plug board connections, so it would specify the pairs of connections. So B and F would be connected, S and D, et cetera, all the way through Z and K. I think the machines came with 10 cables, so you could have up to 10 plug board connections. And these are the key settings. We'll get into this in a moment. That's in the next page, but you would also set a key. So let's go into the main application view now. So anyway, here's the main screen. This is a picture of an actual M4 model. As you can see from the tooltip, I got this image, or I adapted it from Crypto Museum. The basic elements are, this is the keyboard. This is where you would type in the letters. Anytime you type in a letter, the encrypted version would illuminate here. So this is the lamp board panel. This is the plug board down here, but it's not accessible from this view. It's only accessible from the configuration dialog. And up here are thumb wheels that allow you to rotate the rotors, and the letter or number appearing in these little windows indicates the position of the rotor, so that the rotor's position is modified by the ring setting. So this is where you would set that daily key that I showed you, right? These key settings, the operator would choose from one of these and then rotate the wheels. So let's just say the key for the day was, UEDX. And then you type away. So when you press a letter like H, you can see the encrypted value is D. Here you have the your plain text input, and the ciphertext output is over here. E, L, L, O. Of course, the real machine doesn't have these little printouts here. Someone actually has to stand there and watch to see which letters illuminate when the guy entering the message is typing away. Type a little more. You can see hello world. You can see that it outputs the ciphertext broken up into 5-letter groupings. I think the Kriegsmarine used 5-letter groupings. The Wehrmacht used 4-letter groupings, and so in this application, the machine text will do that. So if we had the Enigma 1 model here, these would be divided up into 4 character groups. One of the interesting things, and also notice that as you type in letters, like if we type in another one, you'll see that this rotor is going to change position, right? So it changed from F or whatever it was to I. It must have changed from H to I. The Enigma was a so-called symmetric cipher machine. So as long as you restored the machine to the original settings that you started the message with, then if you type in the encrypted text, it would come out as the unencrypted text, as the plain text. So let's try that. We'll reset the machine to its original position with the keys already dialed in. So what was it? D, W, U, F, and Z. Sure enough, it's decrypted to hello. Okay, I'll just run through a few more features and then wrap this up. In addition to entering text in with the on-screen keyboard, you can also use your physical keyboard. So just to briefly demonstrate, we'll clear the table, we'll reset it to the key position, and now I'll just use my regular keyboard. Well, I mistyped it, but when you're using your physical keyboard, you notice the Enigma machine doesn't have a space character or any kind of punctuation characters. When you're using the physical keyboard, you can put in spaces. So there's a space character. You'll see it only encodes the actual alphanumeric or the alphabetical text. It ignores the space characters. In reality, because Germans, like other people, enjoy using punctuation and space marks, each service had its own conventions for using these characters to represent punctuation and spaces. So this feature is not really implemented yet, but this allows you to use the Wehrmacht or Kriegsmarine punctuation. So like here, you can see from the pop-up, or a period, they would use an X for a colon, 2 X's, comma. I'm not sure what they use for spaces. Further research necessary. Anyway, a few other features I'd like to add. First of all, I really need to tame these pop-ups, the tooltips. They pop up too quickly, and unfortunately in this version 6 of Qt, there's no way to programmatically set the pop-up delay time. So I'll have to figure out a workaround. In any event, a few other features I'd like to add would be the ability to just open plain text files and have them automatically encrypted or decrypted without having to type it in manually. I'd like to give the user ability to copy text from somewhere and paste it in here and have it be encrypted or decrypted. Also, I'd like to give the user the ability to use the backspace character to undo entries. That's going to take a little bit of work because it'll be a little bit involved because I'll have to adapt the rotor stepping function to be able to go backwards, which is going to tax my brain. In any event, I'm going to put the code for this project up on GitHub eventually. When it is, I'll put the link in the description for this video, and if you have any critiques or comments or suggestions, you can make them here, or you can make them in the GitHub repository. And as always, thanks for listening.